Welcome to the deep dive. Today, our mission is to take a really dense industrial product spec sheet and just cut right through the noise to get to the core insights. And our focus today is a very specific piece of tech. It's the NTI E-ULT25IS, intrinsically safe ultrasonic level transmitter, 25-foot range. Okay, that's a mouthful.
It is.
So let's unpack it. What is this thing actually doing?
Well, think of it as a really reliable eye for industrial tanks. Its whole job is to calculate distance, level, flow, and volume.
Okay.
And it does that for both linear and, non-linear tanks. It's all about process control without ever touching the actual stuff inside.
Right. And with these things, knowing the limits is almost more important. The first spec that jumped out at me was the operating range.
Ah, yes.
It's 1 to 25 feet for liquids, but then it drops to just 1 to 10 feet for solids. Has a huge difference. Why does it lose so much range with something like, say, a powder?
That really comes down to the physics of it. I mean, the ultrasonic signal needs a clean reflection to work properly.
A flat surface.
Exactly. Liquids give you that perfect, smooth surface. But solids, like grain or cement, they settle at what's called an angle of repose.
So it's not flat at all.
Not at all. It's an uneven, textured surface, and that scatters the signal all over the place. It just makes a reliable reading over a long distance almost impossible.
Okay, so that's a major trade-off. Now, let's get to the most important part of its name. Intrinsically safe. This has to be what's driving that $2,310 price tag.
Oh, absolutely.
This isn't just about being tough, is it? What's the real difference between this and, say, something that's just explosion-proof?
That is the key question. So intrinsic safety is a preemptive guarantee for hazardous areas. We're talking Class 1, Division 1.
The really dangerous spots.
The most dangerous. Think explosive vapors, volatile solvents. Now, an explosion-proof box is just designed to contain a blast if it happens.
Right. It contains the fire.
Exactly. But this, the E-ULT25IS, is engineered to never store or release enough electrical energy to cause the spark in the first place.
So it prevents the problem entirely.
That's the premium. You're paying for that preventative engineering.
So with that high price and that critical safety function, how does it actually change how you install it? How do you power this thing safely?
Right. Well, it adds layers of complexity. It communicates with a standard 2-wire 420 MA output, and this is a big food, but it is not a standalone device.
So it's not just plug and play.
Definitely not. To limit that energy, it has to be powered by specific external units like the E2D or 5D. It's part of a whole system.
And I'm guessing that's where the costs start to stack up because you can't just wire it to any old power source in a hazardous area.
You can't. And that's the rule. When you're in those locations, the system legally requires an add-on called an EISCB, intrinsically safe barrier.
What does the barrier do?
It's basically an electronic gatekeeper. It makes sure that no matter what happens outside the tank, even a massive power surge, not enough voltage or current can ever get into that hazardous zone to create a spark.
Got it. It's a safety choke point.
That's a perfect way to put it. And speaking of being robust, the housing is IP65 rated, so it's built to resist dust and water. And you get a pretty decent cable length to work with, up to 1,000 feet.
So if we boil this whole deep dive down, the two big takeaways are, one, its specific measurement, ability level, flow, volume.
Right.
And two, the critical safety rating that makes it all possible. Intrinsically safe for Class 1 Division 1 areas. It basically trades some performance for absolute compliance.
And that, it raises a really important question for anyone operating these kinds of facilities.
Okay.
Given that you absolutely need this kind of equipment, what are the hidden costs? Not just the $2,310 list price, but the mandatory barriers, the special power units, the more complex installation. How do you factor all of that into your real safety budget? That's something for you to explore.
A great thought to end on. Thanks for joining us for the deep dive.